MBA633 instructional video prepared by Professor Amit Datta, School of Management, George Mason University. In this video, we will focus explicitly on the use of the Excel built-in function binomdist to compute binomial probabilities. The assumption is that you know the theory behind the binomial distribution. So let's take a specific problem setting that we will use to demonstrate the use of this function. So government data from recent years shows that 56% of startups made it to their 5th year. Okay, so the experiment is the following. So in early 2019, a venture capital company gave money to 15 startups, and you want to count how many of those 15 startups made it to their 5th year. That is represented by the random variable x. So x can obviously take on the value 0, 1, 2, 3, 4 because that's how many startups out of the 15 would make it to their 5th year. Okay, so if we think of the sample space and we start building the probability distribution, so here's the random variable x. X can take on the value 0, 1, 2, 3, 4, 5, all the way up to 15. So anywhere between 0 and 15 out of those 15 startups could make it to their 5th year. And you can use the binomial distribution to compute each one of these probabilities. Okay, why can we use the binomial distribution? So a quick check, the experiment consists of 15 identical trials. So for each startup we want to ask, does it make it to their 5th year? The second startup, does it make it to the 5th year? The third startup, does it make it to the 5th year? All the way up to the 15th. So the experiment consists of 15 identical trials. If you focus on any one trial, there are only two outcomes. Either the startup makes it to the 5th year or it doesn't. So every trial has only two outcomes. Then I think it's reasonable to assume that the likelihood of a startup making it to the 5th year remains the same from one startup to the next. So without knowing additional information about the startups or the economic conditions under which they're doing, there's really no reason to assume otherwise. And the last assumption is that whether or not one startup makes it to the 5th year has no bearing on whether or not a second or a third startup makes it to the 5th year. So the trials are independent. So a quick check tells you that the binomial distribution probably applies. So with that discussion, let's try and compute these probabilities. So the first problem says exactly 5 of those startups will make it to the 5th year. So to write it in shorthand, what we are asking for part A is, what is the probability of x equal to 5? What is the likelihood that exactly 5 of these startups will make it to the 5th year? So here what I'm asking for is the height of exactly one spike, x equal to 5. So I'm looking for the likelihood of exactly one outcome. Okay, so I will use the binomdist built-in function. So here we go. So equal to binomdist. Now there are 3 different parameters that have to be supplied. The first is what is the value of the outcome? So you have to specify that I'm looking for 5 of these startups to make it to the 5th year. How many trials do we have? 15. So 5 out of the 15 make it to the 5th year. The likelihood of any one startup making it to the 5th year is 0.56. So the likelihood of success is 0.56 for any one trial. And this last parameter is what I'll focus on, cumulative. So since here for part A we are computing the probability of exactly one outcome, namely x equal to 5, there's nothing cumulative. We are not adding the likelihood of more than one outcome. So we are focusing on exactly one outcome. So this will be 0. It's not cumulative. Okay, so the probability of exactly 5 out of the 15 startups making it to the 5th year is 4.5%. That's what we are being. That's what the computation is telling us. Now let's look at part B. It says at most 4 of those startups will make it to the 5th year. In shorthand notation, what we're looking for is the probability of x less than or equal to 4. Okay, so at most 4. So this is really the probability of x equal to 0 x equal to 0 plus the probability of x equal to 1 plus the probability of x equal to 2 plus probability of x equal to 3 plus probability of x equal to 4. Now this is gets a bit tedious, you can see. So for each of these probabilities I could use the binom dist function like we did in part A and add up those 5 numbers. Okay, but you can easily see if instead of 4 this had been 7, then it just gets to be terribly tedious. So there is a shorthand way in which you use the last parameter here. So we'll do binom dist. We are still again looking for 4 successes out of the 15 trials. The likelihood of success on any one trial is still 0.56. But now, unlike in part A, this cumulative parameter is set to 1. Why? Because we are looking for the, we are looking for the probability of 5 different outcomes together. So cumulative from 0 up to 4 cumulative. Okay, so notice that when you put 4, the outcome 4 is included in the calculation as well. Okay, so x less than or equal to 4, this is the one. You can do it all in one fell swoop. I'll put 1 as the parameter and here's the answer. Okay, so the likelihood of 4 or fewer startups making it to their 5th year is simply 2%. Okay, so now let's look at part C. It says more than 9 of those startups will make it to their 5th year. So here we want the probability of x greater than 9. More than 9 startups make it to the 5th year. Now in Excel, the binom dist function does not tell me the right hand side, so to speak. So for part C, what I'm looking at is from, let's say this is 9. So I want these probabilities, excuse me, not, I want the probability from 10 through 15. I want these outcomes, I want to add them up. Okay, what binom dist, what that built-in function will do is tell me the probability of everything from 0 up to a certain value. Okay, so I want to take that into consideration. So I can simply rewrite this for convenience. This is equal to 1 minus probability of x less than or equal to 9. So please reflect on this for a moment. The probability of x greater than 9 is the same as as 1 minus the probability of x less than or equal to 9. Okay, so once I have this expression, then the rest of it is very easy to compute. Let's first compute binom dist 9, 15, 0.56, 1. This number, this binom dist 9, 15, 0.56, 1 gives me the probability of x less than or equal to 9. Okay, so all I have to do is 1 minus this number. So the likelihood is 28%. So let me write this out. The probability of x greater than 9, I can't get this directly, so I just rewrite it a little bit for convenience, is 1 minus the probability of x less than or equal to 9. This is very important, this less than or equal to 9. It's not x less than 9. Okay, so the probability of x greater than 9 is equal to 1 minus the probability of x less than or equal to 9, and this is equal to 1 minus binom dist of 9, 15.56, 1. So a little bit of moving around, just algebraic, fairly simple to do. Okay, So the last problem that we'll do, part D. So this is, it says no less than 5 and no more than 10. Okay, so I want 5 less than or equal to x less than or equal to 10. That's the probability that I want. So I want the likelihood of no less than 5 and no more than 10 of those startups will make it to their 5th year. Okay, so again, if I were to rewrite this a little bit, I hope you'll agree that this is equal to probability of x less than or equal to 10 minus the probability of x less than or equal to 4. Notice that it changed to 4. So just reflect on that a little bit. So this fellow is equal to this. Okay, so this is equal to probability of x less than or equal to 10 minus the probability of x less than or equal to 4. So this would simply be binom dist 10 15.561 minus binom dist 4 15.561. So let's actually do that computation and see what we get. Equal to binom dist 10 comma 15 comma 0.56 comma 1. That's the first number, and the second number is binom dist 4 comma 15 comma 0.56 comma 1. Okay, so those are the two numbers corresponding to this one and this function. You subtract the two minus this fellow, so it's 84%. Okay, so the likelihood that no less than 5 and no more than 10 of these startups will make it to their 5th year is 84%. That's what we found over here. All right, so basically this built-in function allows you to compute the binomial probabilities fairly conveniently. The one thing you have to be really careful about is this less than or equal to. You know, where should you use less than or equal to? Should it be 4? Should it be 4 or should it be 5? You know, going from here to here. So with a little bit of practice, that should become fairly easy to spot. But this built-in function allows you to compute binomial probabilities very conveniently.